Greetings, detectives. Mrs. McKay here, and it's time to start on case 9, which is called Crafty Constructions, and you'll get an idea why I call it that once we get into the lessons. Our first clue is learning target clue 9.1, and let's go ahead and fill it in. I can use the Pythagorean theorem to develop and use the distance formula. I can use the Pythagorean theorem to develop and use the distance formula. Now, before we go any further, let's do a quick review of the Pythagorean theorem. This is something that you should have learned back in maybe 7th grade or so, but sometimes we need a little refresher. So, take a look over at my review section, and you've got a right triangle, and that's what a Pythagorean theorem is used for. It's used with right triangles. There's this cool thing about right triangles. Remember, a right triangle has a right angle, and a right angle is 90 degrees. And the Pythagorean theorem uses right triangles. We also need to know what the parts of a right triangle are. We've got the part that's across from, that's opposite the right angle, and that's called the hypotenuse. And then we've got the other two sides of the triangle are called legs. That's important because we use in the Pythagorean theorem, we say that one leg is called leg A, one leg is called leg B, and the hypotenuse is called C. And the Pythagorean theorem, you may remember it. What is it? A squared plus b squared equals c squared. Now, there's some really cool things that they do with squares and area to help you understand what how the Pythagorean theorem is developed. And if that's something that interests you, I would encourage you to look it up, but I'm not going to spend the time talking about it now. Okay, a squared plus b squared plus c squared. All that means is we can figure out what the opposite side, what the hypotenuse is, if we know what a and b are, because we know that a squared plus b squared equals c squared. So let's do that. A squared plus b squared equals c squared. So our a in this particular situation is 3. So 3 squared plus b squared, b in this particular situation is 4, equals c squared. And then we say 3 squared plus 4 squared equals c squared. So 3 squared is 9, plus 16 equals c squared. 9 plus 16 is 25, equals c squared. So c does not equal 25, but c squared equals 25. And the way that we find the solution to a squared variable is we take the square root of both sides. So if I take the square root of c squared, that means I have to take the square root of the other side. Okay? So what is the square root of c squared? Well, what number times itself gives me the number inside c squared? Well, it's c. Okay? And then what is the square root of 25? It's 5. So that's a quick review of the Pythagorean theorem. Why don't you go ahead and do this next one? 5 squared, 12 squared, or 5 and 12. Figure out what c is. Okay, did you come up with c equals 13? If you didn't, then pause this video and review my work over here and see if you can figure it out. If not, you need to go back to the fact file and watch some videos regarding the Pythagorean theorem. We're moving on. Okay, slope. Slope is another thing that we've learned. We always talk about slope being rise over run. That means how much is the line moving up and down over as a fraction moving side to side. And so what we're looking for is we're looking for the change. This is a delta sign, which means change. The change in y over the change in x. And the one way, the formula that you may have learned, I never worry about it because I just always think about the change, but one formula that people use is when you have 2 points, you can figure out what the slope is by subtracting the y's and subtracting the x's. So you pick a first point and a second point, and you take your second point, you subtract You subtract the y's in the second point, or the second and first point, and then the same with the x's. So an example would be if I have the point 3, 7, and 2, -1, and I want to know what the slope is between those two, I would use this formula. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. See if you can figure out what the slope of the line is that connects these 2 points. Did you come up with 8 over 1? Well, the way that you should have done it was you should have identified one of your points as your first point and one of your points as your second point. I chose 3, 7 to be point 2 and 2, -1 to be point 1. And then I did 7 minus -1, so my y's I subtracted, 7 minus -1, and I put that over my x's, 3 minus 2. So 7 minus -1 is really 7 plus 1, so that was 8. 3 minus 2 is 1, and 8 over 1 is my slope. That's an important thing to remember. You're going to be doing that using the Pythagorean theorem and figuring out the distance between 2 points, like how long, what's the distance, and slope is going to help us. Okay? Let's get going. So let's connect slope and the Pythagorean theorem. Take a look at this little graph that I have here. Here I have a line segment, and I'm going to actually put the endpoints, and you can see that we're going to call it line segment AB. And what I want to know is how long is this line segment? How long is it? What's the distance? I want to be able to measure that. So the way that I do that is I create a triangle. I create a right triangle, and I did that with this point C. So you can see that if I took my triangle, or if I took my point A and I extended it all the way over to here, and I brought my point B down to here, I've actually created this little triangle. Do you see it? A, B, C. So now I have a right triangle, and I've made there's a right angle right there, right? Because the graph itself, the grid itself, is making the right angle. Now the next thing that I want to do is I want to be able to figure out what the length of AB is, and I can figure that out using the Pythagorean theorem. So if I know the length of this side of the triangle, we'll say this is A, and if I know the length of this side of the triangle, which is B, then I can do a squared plus b squared equals c squared, and I can figure out what the length of that triangle is, right? So let's go ahead and do that. What's the length of A, or AC? Well, you can see that it's 1, 2, right? So I'll say 2 squared, and B is 1, 2, 3, 4, 4 squared. And that's going to equal c squared, which is my AB, my hypotenuse. So let's go ahead and do this. 4 squared is 4, or 2 squared is 4, plus 16, am I doing it right? Equals c squared. Now, 4 plus 16 is 20, and 20 equals c squared. Now, a common mistake that many make is as soon as they see 20, they're like, oh, c must be 10. But if I take the square root of both sides, the square root of 20 is not 10, because 10 times 10 does not equal 20. 10 times 10 equals 100. So c equals the square root of 20. Now, you might be wanting to figure out something that you can do to simplify this, and you can. You can't find a perfect square. There isn't a perfect square, but you can simplify this even more. And the way that we do that is we take the number that's inside our square root, underneath our radicand, and the radical, and we break it into factors, and we see if any of those factors are perfect squares. So 20 is 4 times 5, right? So the square root of 20 is the square root of 4 times 5. Or I could say the square root of 4 times the square root of 5 equals c. Now, do I have any perfect squares? Yes, I do. The square root of 4 is 2. Is the square root of 5 a perfect square? No, it's not. There's no number that I can multiply by itself that will, well, no whole number that I can multiply by itself that will give me 5. So I say that this is 2 times the square root of 5 equals c. So AB is 2 times the square root of 5. Now you may be tempted to pull out your calculator and try to get a decimal. I don't want you to. I want you to keep it in this radical form. Unless you're asked to round to the nearest tenth or round to the nearest hundredth, keep it in its radical form, but simplify it as much as possible. Okay? Now, that was pretty easy because it was on a graph, and we could actually figure out the point or the sides by simply graphing or by simply counting on the graph. But what happens when I have a point that or something on a graph, like look over here where it says a little practice, where I have an A and a B, and all we have is the points. Point A is 2, 1, and point B is 5, 16. Then we're going to have to figure out using slope to be able to figure out the lengths of the sides. Let me show you how that works. So again, here I have a graph, right? Or a line. And I'm going to go ahead and create my right triangle and create my point C. Now my point C doesn't mean anything. It's just the vertex of my triangle. So take a look though and see if you can tell me what is the slope of AB. What is the slope of AB? Well, the slope of AB is rise over run. So we went from this point right here, down here, and we went up 1, 2, 3, 4, 5, 6. So we went up 6. And we went, so let me put 6 here, over 1, 2, 3, 4, 5, 6, 7, 8, over 8. And that is the length of my sides, isn't it? Up 6 would be 1, 2, 3, 4, 5, 6, and over 8 would be the length of AC. Do you see that? Do you see how the slope of the line is actually the length of the sides? When you have the hypotenuse and you figure out the slope of the hypotenuse, you can then figure out the length of the sides. And you can do that if you have 2 points, because we know that if you have 2 points, you can use this rise over run and think about how far you had to get from one point to the next point, or from one coordinate to the next coordinate by subtracting or finding the difference. So go ahead and figure out what the length of this line is with this slope of 6, 8. Do not reduce it. Keep it at 6, 8 because 6, 8 is actually the length of the sides. So go ahead and figure that out. So did you figure out that the length of side AB is 10? If you didn't, take a look at my work down here and see if you can figure out what you did wrong. All right, now let's talk quickly about deriving the distance formula. The distance formula looks long, it looks big, it looks scary, and I never memorize it. I use the Pythagorean theorem because the Pythagorean theorem is going to help me. If I know how to use the Pythagorean theorem, and if I understand slope, I never have to memorize the distance formula. But I can always figure it out. So let me show you what I mean. First thing I want to do is I find the length of the horizontal leg of the triangle. So the horizontal leg of the triangle is this one right here, A to C, right? And the way that I figure that out is by using slope, which is this x sub 2 minus x sub 1. So if I take that, okay, that's going to give me the length of my horizontal slope, right? From here to here. If I subtract those, I'm going to get my slope, or not my slope, my horizontal leg. Then I find the length of my vertical leg of the triangle, which is going to be from here to here, right? And that's going to be y sub 2. It's not, I wrote that wrong, minus y sub 1. So I fixed it, x sub 2 minus x sub 1. And then the length of the vertical leg is y sub 2 minus y sub 1. And now I need